We've dramatically refined your direct modeling capabilities with the new Deform tool. This means you can bend, taper, or create a bulge with practically any geometric object. We've also expanded the functionality of the original Twist tool to include new modes and options, making the possibilities endless. Not to be confused with the Taper Face tool, the Taper Solids mode of the Deform tool will taper an entire object all at once, rather than just one face. To use it, activate the tool and select the desired object. First, we'll showcase the Symmetric mode. A four-way arrow graphic will appear, indicating that the object will be tapered in all directions. The location you place the UI element determines where the selected object will be tapered to. The next click will determine the sensitivity of the taper operation. For instance, if we don't click far from the four-way arrow element, the taper changes dramatically with just small movements. If we perform this operation again, but this time set that second to last click far from the arrows, we see that we have much more granular control over how far the object is tapered. This line effectively sets where the minimum and maximum will be for the taper operation. If we drag past the end of that line, the taper will expand in the opposite direction. As you can see here, the location of the four-way arrow indicator controls the direction from which the taper objects toward or away. Placing this indicator on the top or bottom centers of this object, taper it directly away or toward that point. However, if we place it to the side of the object, we can see the taper moves toward or away from that point as well. Note, if you happen to place the indicator in the wrong location, simply press Delete on the keyboard to back up one step and replace it. If we now enable the Asymmetric mode, we see that the indicator becomes a two-way arrow, showing us the directions in which the object will be deformed. For the previous example, since it was tapering symmetrically, the direction of the four arrows did not matter. For asymmetric tapering, it's important to indicate which direction you want this taper to go. After selecting the object with the Deform tool, the next click will again indicate the focus point of the taper, but now we must indicate in which direction we want the taper. This is set in the same click that determines the sensitivity of the Deform tool, as explained earlier. Now, when we taper the object, we see it being deformed in the two directions indicated by that arrow. For both of these modes, you can enter a ratio for the taper. For example, a cylinder 1 meter across and tapered at the top with a ratio of 2, entered via the floating data bar, would be 2 meters across at the top and 1 meter across at the bottom after the taper completes. As with the taper mode, we first select the object and then see a four-way arrow indicator. This shows the point from which the object will bulge toward or away. However, you will also see a dotted line. This line will stretch from one end of the selected object to the other. This dotted line is the target from which the bulge will either move toward or away. As you can see here, when we use Symmetric mode, the object bulges away from or towards this line in all directions. If we place this indicator outside the object, the bulging away or towards the indicator line becomes more obvious and allows for more abstract shapes to be created. If we disable the Symmetric mode, the bulge operation will only move in the two directions designated by the indicator arrows. Here, we see the object being warped both side to side and front to back. If multiple objects are selected, they will be bulged away from or toward a similar point, but each of them will be modified in a different way, depending upon the location of the indicator. Previously, the only way to create an object with multiple turns and bends along it was an extrude-along path. However, it was difficult to use if you weren't sure how much of a bend you wanted or needed before you drew the path object. To fix this, we've added the Bend Solid mode to the Deform tool. This tool allows you to select already existing 3D geometry and bend it via an easy-to-use graphical user interface. Unlike the previous two modes, Bend has another controlled mode, Finite Length, which we will cover shortly. As with the other modes, first select the object. Then, the next click will determine the point where the object will be bent. If you place this modifier at one end or another of a straight object, that end will remain where it is and the other end will be bent. If you place this modifier in the center of the object, the two ends will be bent and the middle will remain in the same location in Symmetric mode. If you disable the Symmetric mode, then the object will only be bent between the bent point focus and the end of the drawn out line. The point where you place the feedback indicator, and then the next click, determines the start and end of the bend. If these two clicks are both at opposite ends of the selected object, then the whole object will be bent. If the clicks only go from one end of the object to the center, then the remainder of the object will be left as it was. However, this tool is far more than meets the eye. Here was a complex extrude, custom made from a series of polygons. In previous versions, there was no easy way to manipulate the path of this object after it had already been created. If we wanted to wrap this object around a curved wall, or otherwise alter it, there was no method of doing so. Now, we can simply enter a top view, click once at both ends of the object, and bend it to any desired degree, even wrapping it into a complete circle, 360 degrees.